I texted her and told her to send me a text when she's able to join us,
Okay.
and so hopefully she'll be able to join us sooner rather than later.
Okay.
Um,
Alrighty. So we're just gonna take the quiz, right?
yep, let's just jump straight into the quiz and go
So
at it.
the only ones I haven't done on the quiz so far is in and then 11 through 15. So I'm missing like 5 or 6.
Okay.
Okay. Um, okay, so in previous lessons we've assumed the population standard deviation was sigma was known. In this lesson we were making a different assumption about sigma. What has changed?
That
Okay,
one's
this should.
super easy.
Okay, I don't even remember this. Is it? We assume it's always one, or
We assume sigma is unknown.
okay. Well, I know that that's what this whole lesson was about, but I wasn't sure if we made a different assumption because of that.
Yeah.
Okay. All right. So it's because
Okay.
we're dividing it by. Is it because our n value is changing? Is that
With sigma being
or
unknown.
yeah, yeah. Because
No,
I
I
guess our
what's
go
that?
ahead.
Oh, I was just gonna say
I
this
said go ahead.
from I guess just from everything that I read, this lesson just taught us all the formulas and everything we needed to know in order to calculate like t values and the other values, just with sigma being unknown.
Okay. All right. Sounds good. Hmm.
So what do you
Okay.
guys want to take this next one?
What's that?
I'll see. Yeah. I'll see if I can do this one here. Null hypothesis H naught is the mean is equal to 8, and or mu is equal to 8, and the alternative hypothesis that's HO. Whoops. And so yeah, HO is mu is equal to 8, and the alternative hypothesis is it's greater than 8. So the population standard deviation is not known. Becker collects a sample size of n equals 9 and computes x bar is equal to 11 and s is equal to 6. Use this information for questions 4 and 5. So, let's see, is omega, is it known? And so it says it's not known.
Yeah, so no.
Yeah, that was really simple, I guess. But
Yeah.
I was like, are they asking us? This is like a trick question. So, yeah, 5. What is the value of t?
So this
Um,
one in the videos, it gives you the
mm-hmm,
like the exact formula to follow. And
mm-hmm,
yeah, it's super easy. The formula is just it's x bar minus, let's see. Yeah, x bar
mu.
minus, yeah, mu divided by s over square root of n.
All right. So x bar, what was x? So 11 minus 8 over s, which is 6 divided by 9. So 3 over 2. So it would be 1.5.
Yeah, that's what I got.
Okie dokie.
Sweet. So
Perfect.
now this is where it gets a little tricky. I've been able to use SPSS for this, but
Mm-hmm.
it's talking about copy and pasting this into our software. Now, I learned how to do it. I learned how to make graphs and everything with all those numbers. I just hope that it's right because I've never done it like that and it never taught us how to do that.
How to copy and paste?
Yeah, just making sure that we're using those correctly in the software, you know. Because what
Right.
you
Mm-hmm.
can do, you can copy paste it into SPSS, and then it'll go underneath a column that's called variable 0002, and then it's pretty sweet. You can just go up to
Right.
yeah, you can just go up to like explore and all that stuff, and it gives you all the same stuff. I just hope that it's right, you know.
Uh-huh.
Right.
Yeah, I have to pull up my like other screen. I can't do it on the normal thing. Do you guys have SPSS up, or should I open up mine? Are you guys good?
I got it up.
Okay, cool.
I don't use SPSS because I've never really been able to get it to work. Like I don't know if you guys have to do this. I have to remote access one of like the school's computers and then use SPSS from there. And so like I would have to open a completely new Explorer and get logged into my BYUI and open up this quiz again type of thing.
Oh, nice.
So I use Excel for the most part, but
yeah, I guess there's like, yeah, I don't know if I'm trying to describe the same thing as you. It's like something I just click on my desktop, and it opens like a laptop. It gets called the laptop, but it's like inside like my laptop, so it's like a computer program. It's like almost an entire computer programmed into my computer. I don't really get it, but is that it?
Well, it's remote accessing a school computer, or like
Oh.
I don't know if it's like a school computer necessarily, but that's the idea, is that you're remote accessing
Something like it, yeah.
a computer that
No,
they
I think
have over there. And it's more of a pain to use than anything.
Mm-hmm. Yeah. Cool deal. So are we finding just X bar then let's see, for number 6 then?
Yeah, so we just need to replace those things.
Did they ever give us a formula for S on number 7?
Number 7? Yeah. See, S is what I'm trying to figure out, because S is the, isn't that the sample standard deviation?
Yeah, or like our assumed standard deviation, yeah.
Yeah. Hold on, I'm like right on, because when we pull up, so you can pull up body temp as the SPSS. There's just a bunch of different things. Did that third video help you out at all, Joe?
Yeah, it did. I just didn't watch it carefully, I guess, the first time, because it was pretty clear.
Yeah, it made it nice.
Yeah, it was pretty clear. So.
Okay, so
yeah,
I can
that, yeah.
I can get that, and then I can go to Analyze, Descriptive Statistics, Explore, and then I can put variable 2 in there. Statistics. Oh, nice.
So I think our standard deviation for the information given, like that would be S using just the 20 points of data we have, to 3 decimal places is going to be 0.922.
Okay.
And X bar. Oh gosh, I am tired.
Also, here's a histogram, as well as the two plots.
So X bar is 0.922?
No, S. So number 7.
Oh, I was gonna say, I thought that was, yeah, that didn't sound right.
No, yeah, your mean or X bar should be in
Okay.
like the 90s.
And so, let me set this here. So
Yeah.
body image. Now, this is kind of the tricky part with this. If you're doing a hypothesis test, you have to put the null hypothesis right here under test value. I'm going to put in the null hypothesis that will give us 98.6. Okay. Now, you can also change your level of confidence here if you want. But if we click on OK, then we will get our results down here. Here is our test statistic down here. And our p-value. Well, it's usually, if this is a two-sided test, these videos, this would be our p-value. However, if this is a one-sided test, then we have to divide this number in half. Now, in this case, the number is close.
And would 98.22 be our X bar or bar X?
However, we can't really.
That's what I got.
Right here.
Okay.
But I'm going to get a confidence in it. We'll use the one-sided test for confidence.
So then our T-score is
SPSS.
pretty easy to figure out.
Then what we do is we put this.
I think I have it. Because when you put the...
So, in summary, minus f of t. After you, to do the hypothesis test, you have to put in the null hypothesis here. But if you're doing a confidence interval, you leave this.
Because you can put that in.
What exactly is T2 down?
Descriptive statistics. You can put in outliers, percentages, percentiles, and then plots. You can do a normality test with plots, a histogram. And then you can hit continue. So, like in this, it's calculated a standard deviation of 0.922.
Okay.
That could possibly be it.
For what?
What's that? Yeah, I think the answer is 0.922.
For S?
Yeah, that's what it
Yeah,
says.
that's what I got.
That's what you got too?
Yeah.
0.922.
So do you guys want to know I just found out about Microsoft Excel?
What?
I think I can figure out exact numbers regarding students' T distribution.
Oh, no way.
Right-tailed.
For
That's pretty
number
awesome.
for number 8 on the T score, did you get 476.407?
For what?
For the T score?
I haven't calculated that one yet.
Oh, okay. Holy moly. $98.6.
Whoa.
I think I got an email, sorry.
Oh, no way.
What?
So if that one's two-tailed. Oh, okay. So number 8, I finally did that one right. So I got
Sorry,
number
what?
9. Number 9, the p-value is the p-value is 0.0401. Hold on, let me divide that in half. .081 divided by 2. 0.041. 0.041. So that means for number 9, since it is below, what's the level of significance that we use? 0.045. So yeah, then we would reject 10. We would reject the null hypothesis because it's less than 0.04541.
Okay, so wait, what did you get for the T score?
For some reason, I put 476.407. I don't know if that's right though.
Okay.
Wait,
so-
no, T score. No, we just need to calculate it.
Well, what do we use? Do we use our null hypothesis mu? So 98.6?
Yeah.
Okay.
Oh, and then we would go minus S, right? Or let's see, what is that? What's that formula again?
Divided by S divided by square root of n.
Oopsie.
I got 0.483.
As
Zero
your as
T-score.
what? As the t-score?
Yeah, 0.483.
0.483. You get
Does
that through Excel.
Yeah. Well, I did that calculating out using our formula. I didn't use Excel for that. I can't
On
figure
the
out on Excel.
on SPSS it says it's negative 1.843.
I'm gonna trust that.
Yeah, that honestly I think that's right actually. Negative 1.843. Can we put negatives in here?
Yeah.
Negative 1.483. No, negative 1.843, sorry.
Okay.
I'm going to double check on that real quick just to make sure that that's what it's talking about.
For the requirement. Confidence here. Here is our test statistic down here. Our degrees of
That's
freedom
the
and our
test statistic. Do you think the t-score is the same as the test statistic?
I think it is.
Yeah, that's what I think. I think it says that here.
Oh, okay. Sweet. Yeah, I think we got all those right.
Awesome.
So
Okay.
down to 11.
Can we run over those quick? So we got 7. I got 6 and 7, and then I was trying to set up my SPSS the rest of the time.
Oh,
so,
okay.
Yeah, my 8. Let's see. Our t-score was
Negative 1.843.
negative 1.843. Okay.
And then number 9 is the p-value is 0.041.
0.041. Okay, and those are on the. Those wouldn't be on the
SPSS?
Yeah, those they're in the SPS. But is it the one sample T?
Yeah, that's where you get all those.
Okay.
So let's see. Okay, your first alternative hypothesis is different then. What is the p-value? Oh, okay, this one's not that hard. 11 is not that bad. So I'm gonna open up the baby boom one. Throw this down in there. Command C. Command V. And then
Okay, so I have your average and your standard deviation for you for that baby boom one.
oh, you do?
Yeah.
Atta boy.
Like, assuming it's the numbers that they gave us right here, yeah, I've got it.
Oh, okay.
Um,
Okay, let me just... I'll pull it up and then we can check answers. I'm super close. Almost. Like 5 minutes. Okay. So 11... For 11, I got 0.995. Is that what you got?
I don't think I ever figured out how to calculate the p-value for, like, is it just you use like the t-score instead of a z-score?
Yeah. The p-value is in SPSS. It shows up as the sig for the two-tailed. So in that case, as 0.499, that means number 12, we failed to reject the null hypothesis because it's above our level of significance of 0.01. You decide to try another alternative hypothesis. This time you use, do you keep the same level of significance? Did the p-value, oh nice. P is greater than 40. Did the p-value increase or decrease? So 13, the p-value decreases because it's only a one-tailed test. What decision did you make? You would only divide it by 2. So what decision did you make? You still failed to reject the hypothesis.
So wait, 13 it would decrease.
Yeah.
It would still fail, and then compare the width of the confidence interval for question 11.
What's that?
Hi, sorry, I'm back.
Hey, Naomi.
Hey, Naomi.
Hi, I'm sorry.
So you were saying for 13 we would decrease the p-value in half. Is that right?
Because in the reading it talks about how since it's, see how it's the equal sign and the slash through it? That means it's a two-tailed test. And then the other one is population mean is less than or is greater than 40. It's only a one-tailed test.
Right.
So you would divide it in half.
Okay.
So it would come out to be like 0.4 something, which is still above our level of significance of 0.041, so we'd still fail to reject.
Okay. Got it.
Holy cow, I can't hear you guys. Naomi, are you at a party?
No, it's just pretty loud here. Sorry.
Want to come?
Sure.
So, compare the width of the confidence interval to question 11, the confidence interval question 13. Which one is wider? Since 11 was a larger number, it would be wider,
Rather with the confidence interval. Let me check.
I was taking my clothes off, and I was just feeling myself with a big moment. I was like, here it goes.
So the confidence interval for that one.
The only thing that came was the security guard. What I was doing on the set, so I just sort of seen that. And I realized at this moment, I don't have enough time to put the rest of my clothes back on. I've already presented myself to the lady. Accidentally, I tried to run naked away.
So the confidence interval on that one.
Sounds like it's isn't it the same?
Yeah, I think it's the same.
Because I think what they're asking actually doesn't affect the confidence level.
Yeah, it doesn't.
Yeah. Okay.
Yeah, I think
So that one's
the same.
Yeah, I'm thinking it is the same.
All right, I'm submitting this thing.
And then 14. What was number 14? Sorry. That was
Failed to reject.
failed. Okay.
Hey, number 10. Number 10 is failed to reject. Right?
Hey guys, we got 100.
No, on 10 we rejected.
Oh, we reject it. So it's alpha is 0. Okay, sounds good.
Yes.
Oh yeah. Okay. Naomi, do you need the answers then?
I did some of it earlier, but I don't know if I got them right.
Okay.
So
Hey,
Just
I'm
go
gonna.
through it and go over what we have with you.
okay, yeah, whoever can. I mean, you guys don't have to, but
I have the broadcast, so.
I have to.
what?
Number 11. I put down .499 because I thought that's what we got, but I guess not.
Number 11 is .999.
Oh.
Okay, so Naomi.
Okay, so let me read the answers I have.
Okay.
So number 3, I put we assume standard deviation's unknown.
Perfect.
Okay. 4 is yes.
4 is no.
Okay. 5 is 1.5.
Yep.
Okay. 6 is 98.220.
Perfect. You just have to round it to 2 places, so 98.22 works.
Oh, no, just okay. And then next one, 0.922.
Yep.
And then negative 1.843.
Perfect.
0.081.
We got 0.041.
41. Okay.
Yeah.
And then fail to reject.
With the answer you had, that would have been correct, but
Well, that's true. Yeah.
041
Says
we
reject.
we reject the null hypothesis.
Okay. And then 11's 0.995.
Yep.
And then reject.
Fail to reject.
Fail to reject. Oh. And then 13's decrease. And then reject, and then they're the same.
Decrease. 14 is also fail to reject, and then they are the same.
Fail.
Yeah.
Oh. Oh. Perfect. I didn't do that. I didn't do bad then.
And then submit it, and I'm gonna go ahead and stop the broadcast so that this has time to
Okay.
load. I can get the video posted.
All right. Well, thank you. Sorry I'm so
No problem.
late.
No problem.
Okay. Good night. Bye.
See you guys.
We'll see ya.